thank you for joining us today and welcome to the BDTI Skills Studio. Today we have a very interesting session, which is Dashboard for Data Visualization, Analyzing and Presenting Traffic Accident Insights. Here is a quick overview of the agenda of today. So first we will introduce BDTI. Following that, we will dive deeper into the workshop content. After the workshop, we will open the floor for Q&A session. And finally, we will wrap up with a summary of today's session. Along the webinar, feel free to share your thoughts, ask questions in the Q&A section. Please be respectful when commenting, and we invite to ask questions relevant to the topic. We encourage you also to share learnings and don't forget to register for upcoming workshop session. Now I will hand the floor to Maria Claudia, who will provide an overview of BDTI.
The reason why we are here. So today we are going to have an interesting webinar about using open data from Madrid and try to visualize them in a nice dashboard. All of this that we are going to do with Berta is something you can implement in the big data test infrastructure, that it's a playground for data scientists, but also for data enthusiasm and for people that wants to learn and wants to support public sector. So the big data test infrastructure is a set of open source tools already developed and deployed in the cloud that is completely free of charge. So don't be intimidated by the name of big data. You know, it's not about just big data. For example, today we are going to use a very small data set. So in general, it's for public sector information it's all for open data that are public available from the different institutions, municipality, regions that you could be part on. If we move to the next slide, thank you. In here you can see this circle with the main data journey steps. And for each of them, you can see nice color icons. These are well-known, I would say, data analytics tools that you can find in the market. And they are completely open source. So for each of these data journey steps, so basically for each important stage you need to cover when you are going to approach your data initiative, in our infrastructure, this big data test infrastructure, you can decide between different tools. So today, specifically, then we will show you later, but we are going to focus on the collection of the data from Madrid. We are going to source the information in PostgIS and in PostgreSQL. And then we are going to display some of this data, also these insights, using Metabase. That is one of the tools you can see on the left side at the visualization step. Then if we move next, just to wrap up about BDTI, you know, why and who can really benefit for this, from this initiative. It's for public administration in the European Union. If you are a small municipality, for example, now we are onboarding a small commune, it's not very small, but compared to big cities, yes, in Italy, Comune di Arezzo, we have other cities from Germany, from Finland. If you're a small administration, it doesn't matter. We are more than happy to support you with this big data test infrastructure. Even more, if you're looking for testing and also to get, you know, familiar with data analytics tools, that's extremely is an extreme good opportunity because you can experiment. You just need to define the use cases you would like to implement. We always try to foster collaboration with academia. For example, if you have maybe you have around students that are doing their master thesis, or tech geek guys that want to be, you know, somehow useful for the public good. We are more than happy to onboard them in your pilot. It's the same also with small and the GovTech startups. So you are going to be the one asking and submitting the pilot proposal, but then we can also add other people like students or private companies together with you on the same environment. If we move next, in this slide, you can find a QR code, but again, I will strongly recommend you to visit our website, where you can read more about the current pilots we have, and also the previous pilot we already developed in the past. Here you can find just some example, and I will not spend a lot of time here because I think you can read this on our website. And then if we move forward, I would like to quickly share which is the process, how to apply for this data science and data analytics free playground. It's very, very easy. First, you need to, I would strongly, recommend you to read our website, the information we are sharing in our different section, and try to understand which is your business challenge, your business question that you would like to, let's say, to develop together with this infrastructure. Then we have a very, I would say, a very agile document. It's nothing difficult to understand, where you should describe your pilot. And once you submit your idea, we can meet together, we can discuss together what you want to implement. And usually in a couple of weeks, you are ready to implement. So the only constraints are basically two. The first one is we don't allow the usage of personal data. So that's why we are pushing for open data. And the second constraint is that the public administration is the one that needs to submit the proposal. So we need a European public administration. Then you can find our monthly newsletter. You can find also nice resources like demonstrator of the different tools, canvas to define your idea. So feel free to subscribe to our newsletter, also to check our website. Then if we move next, just to introduce a bit the workshop today. Probably most of you were already following the previous workshop. This is a part of this Skill Studio, BDTI Skill Studio initiative. That is a series of different workshops where we really like to deep dive in something very tangible and concrete. You can look at our previous webinar. All of them have been recorded, and also all the code we develop is publicly available in our GitLab open source repository. And in the first webinars, we were more, let's say, focused on beginners, and we were using some tools, specifically one that is called NIME, where you don't need to really, you don't need to code, and you can just using like visual coding, like drag and drop. Today, we are moving forward, and we are going to showcase other different tools where you are start approaching Python. It is one of the most interesting, let's say, language to play maybe with data, not just with data, but in general in computer science. And we are going to use open data from Madrid to really showcase something that is, in our everyday life. Now I will give the floor to Berta, that is going to showcase this amazing example of using open data for social good. And enjoy this webinar. Feel free to post your question in the Q&A section. Thank you.
So thank you, Maria Claudia, and hello everyone, and welcome to our workshop on data dashboards for data visualization, analyzing and presenting insights. We're thrilled to have you here, and we're excited to dive into today's session. So So in today's world, we're constantly surrounded by data, and it's not just about gathering as much data as we can, but about making sense of it. So data visualization comes into play here. It's when done correctly, it can turn raw numbers into actionable insights and compelling stories. And this is exactly what we're going to see today. So data visualization, we're gonna delve into it today and see the core principles. It plays a key role in any data-based, data-driven decision-making process. And it's crucial for identifying patterns, trends, and outliers to understand what's happening in the real world. This can be either in business or in public policy, or as we'll see today, in urban safety. Dashboards are one of the most powerful tools to visualize data, and they provide a central place for visualizing the key data points. And the best part is that they're interactive. They allow you to drill down and dynamically filter things or to explore a specific area in a very visual and impactful way. So to make all of this more tangible, we're going to work on a very practical use case, which is analyzing traffic accident data in Madrid. And we're going to be trying to answer one main question, which is where are the traffic hotspots in Madrid and what measures can we implement to address and reduce these high-risk areas. So this question is a very relevant challenge for the public sector organizations, which aim to improve urban safety and implement active traffic control policies. So we're going to be working mainly with two datasets, one on traffic accidents in the city of Madrid, which contains data on the accidents that have occurred, and it has been registered by the municipal police. And this is updated monthly, so we'll be working with the latest data. And then another dataset, public dataset, on radar and camera locations in the city, which also has some geo variables, which will allow us to work with geospatial tools like QGIS. So here we're taking advantage of Madrid's open data portal, which is a very powerful tool to access public data and can drive innovation and transparency. There's other portals such as the data.europa.eu, which has millions of open datasets that you can use, and they are free for reuse. And you can draw very actionable insights from that data, so from that open data. Now, opening data really empowers the public sector to create policies and make informed decisions, and fosters public engagement. And then sharing open data increases the transparency, fosters innovation again, and it's a really good way to engage with the community overall. Right, for this workshop, we're going to be using several tools from the BDTI platform for the whole process, from data extraction to visualizing and getting the insights, as we'll see later. We'll be working with Python through Visual Studio Code to extract the data directly from the source, so from the Madrid Open Data Portal. Then we will use PostgreSQL to manage this data, do some transformations, and then we will feed it directly from PostgreSQL through a Python code snippet, basically, to Metabase, which is a very powerful tool for creating dashboards. And then we'll create some geographical visualizations with QGIS. And by the end of this workshop, you'll have a complete end-to-end view on how to turn raw data into real actionable insights that the public institutions can use for urban planning, right? Now that we've covered the core principles and the tools, it's time to walk through a demo. Note that we have pre-recorded this demo for the sake of time and to be able to thoroughly go through each part of the process. But don't worry, we'll still be here in the chat. So if you have any questions, make sure to post them there. And after the recording, there will be a live Q&A session. So you can also ask the questions later if you want us to answer them live. Without further ado, let's just jump into the walkthrough and make sure to pay attention and don't hesitate to ask us any questions. All right, so let's get started by setting up the environment and the tools we're going to be using for creating this project in the BDTI platform. The first thing we'll do is to log into the portal and create the deployments we'll need. So first, I'll go into the BDTI platform website, into the portal, access the portal, and I'll put in our credentials to access. Once logged in, we'll see this dashboard where we can manage our services and projects. Now we're going to set up a VS Code deployment with Python. And to do this, we first need to find the service in the catalog. I'll go to the service catalog and search for VS Code Python. Once we find it, we'll click on Launch, and this will start the configuration process. Next, we need to configure the service. So there are a few important fields to fill in here. For the naming convention, we'll follow a simple format of product service dash initials. So in this case, I'll name it VS Python dash BP. This will help us easily identify the service later, especially if we have multiple deployments. In the sharing status, it's good practice to create a shared instance, so other group members will be able to access the same deployment. I'll select the group. We could have multiple here. And for the deployment size, I'll select the small configuration. This is a predefined setting that allocates the necessary CPU and memory resources for our current needs. But if we were working on a larger project or required more power, we could choose a larger configuration or even set a custom one. I'll select the NFS storage for a project. And once that's done, I'll click on launch. This deployment might take a couple of minutes to set up. So while we wait, I'll navigate to the My Data section. And you'll notice that a new secret has been created for the VS Code service that we just launched, VS Python-BP. So we can click on it and copy the secret, which we will need to access the service later. Once the VS Code service is fully deployed, it will appear in the My Services page. Let's see if it's ready. Click on refresh. And it's not ready yet. So meanwhile, we can just repeat the same process for creating the other services that we will need. All right, we can create the Metabase service. We'll name it Metabase-VP. I'm using the same naming convention that I mentioned before. We'll make it shared for the ClearPix group. We just need a small deployment and launch. Next, we need PostgreSQL. Let's launch. And again, follow the same naming convention. PostgreSQL-BP, shared for the ClearPix group, and a small deployment. This automatically sets an admin username and admin password. We will be able to access it later from the My Data Secrets section that we have seen. And launch. Next, pgadmin. Shared ClearPix, a small configuration. Note that in the pgadmin deployment, it is required to give an email. So we'll put the email. And that's it, just launch. Finally, we will need QGIS. So we're gonna set this up too. We'll make it shared, ClearPix, and small. Select the NFS and launch. Now all of these deployments might take a while, so let's just wait. So after a couple of minutes, all the services are available, and we can see this from the My Services page. With our VS Code environment set up, we're ready to start coding and dive into the data analysis part of our project. So let's move on to that next. I'll click Open, and I will be prompted to enter the password that we copied before. I'll do that again just to repeat. We'll go into the My Data page, locate the VS Python BP deployment, and copy the secret. We'll paste that in here. And once the password is pasted, we'll have full access to our VS Code environment. And we can start working on our Python code from here. So now that we're inside of VS Code, let's take a quick look at the file system. Over on the left-hand side, you'll notice the NFS that we have access to, so the NFS files that we have access to. And these files are part of this shared storage we selected earlier during the deployment. To create a new file here, well, for this project, we'll just actually start by creating a folder. Maybe we'll call it Madrid traffic. So I've created the new folder by clicking on this icon here. I've typed the name, enter, and the folder is created. While keeping this folder selected, we'll add a new file with this icon here. And we can call it something simple, for instance, download data.py, because we want this to be a Python script. See, it has already detected that this will be a Python script. Here we will write the script to download the data directly from the Madrid Open Data portal. So now we have the script ready for downloading the data directly from the Madrid Open Data website, but we'll do a step-by-step breakdown so that each part is clear. First, what we're doing is importing the two necessary Python libraries. The first one is requests, which will allow us to send HTTP requests that we will use to download files from the internet. And then OS, which will help us interact with the file system, like checking or creating folders on the computer, or in this case, in the NFS that we're using. Next, we're defining a list of the two URLs that we need. Each URL is a link to a dataset that we want to download. And the first one is for traffic accident data, and the second one is for the radar and camera data in Madrid. And these files provide the core data that we're going to be working with. After that, we're specifying where on our computer we want to save these files. In this case, we've chosen to create a folder called data, where the downloaded files will be stored. And the following line with OS make dirs just checks whether the data folder exists. And if not, it will create the folder for us. This exist _ equal true part just means that if the folder already exists, it won't give an error. It will just continue with the rest of the code. After that, we're starting a loop to go through each of the URLs in our list. So the two URLs, and for each of those, we will be sending a GET request to the website using the request.get URL command. This is like asking the website to give us the file. When we make a request to download the file, we get a response back from the website. And a status code of 200 means that it was successful and that we could download the file. And if we don't get this code, it means that something went wrong. What we're doing after that is just getting the file name from the URL. So we're splitting it by the slashes. So here, 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 and here, and getting the last chunk. So for the first one, for the first URL, the file name will be this part here, including the CSV. Then we're creating the file path, so the full path where we will store the file. So it will be the download directory, so data / and the file name. So data / this and data / this. Next, we're opening this file path that we have created and writing the content of the response from what we got here. So the file that we downloaded. Finally, if it worked successfully, we're getting a message that the file was downloaded properly. And then if it failed, we will get just the reason or the status of the error. Now this is ready to be executed. So for that, we're going to hit the execute button on the top right corner here. And it's possible that at first we will get some error like this one, for which we're missing a module named requests. So we're going to install it. For the best approach, and the one we recommend, is to create a new file named requirements.txt, where we can list all of the libraries we might need to import. In this case, it's only complaining about requests, so we'll put that here. And close it. If we go back to the terminal, which is the window that popped up when we executed the script, now we have to move where the requirements.txt file is located. So inside of the Madrid traffic folder, we'll do that with cd Madrid traffic. Now we're inside that folder, and here we can execute pip install requirements.txt, and this will install the requests package for us. Successfully installed requests. Great. Now, once that is done, we can just try to execute the script again. And file downloaded successfully, which means that we already have this data, the 2 CSV files that we wanted in the data folder. Let's check it here. We see that now there's a data folder that appears, and inside it has the 2 files that we were expecting. So now what we're going to do next is to upload these 2 files into a PostgreSQL table through pgadmin. So let's go back to the BDTI portal. We'll go to My Services and open pgadmin. This might request a username and password, which we can find it in My Data and pgadmin email and password, which we can copy as we did previously. Let's go back to pgadmin, and we can add a new server to connect to the PostgreSQL table. So we'll name it something simple like PostgreSQL CP and set the connections. We're required to give the address and or host name. We can find it in My Services under PostgreSQL. Copy the address and paste this here. We don't need this last part because the port is already set below. So we'll get rid of this. The database will be named Postgres, and the username and password that we need to give it are again in My Data. So let's find PostgreSQL. The username is Postgres, and the password, we'll just copy that one. So it's Postgres, and the password we copied. Now we save it. And we have the connection established. So we see that it appeared here. Now we're ready to upload the files. We'll do that through a script from VS Code also, just like we downloaded the data from the website, we can upload the data from this environment, this NFS, and put it into a PostgreSQL database. We already have this script ready, so we're going to do a step-by-step breakdown to see what it does exactly. First, we're importing again some libraries. Some of them we're missing from our environment, so we will need to edit the requirements.txt file we created before and add those so that when executing the script, there's no errors there. So we will need pandas, SQL Alchemy, and add them here. So under requests, pandas, Alchemy, and we'll also need Psycho PG2. Now that's ready. We'll go back to upload data. Next, we're setting the PostgreSQL database credentials. So just fill in the username, password, host port, and name. We'll get them, the username and password from the My Data secrets. So from PostgreSQL, the password, and the username, which is Postgres. We'll paste the password here. The database host, which we can get again from My Services. The port, which is this last part. And the database name, which again, remember we set it as Postgres. Next, we're setting the path to the download directory, which is the data folder that we created before. And inside of it, we're also creating a list of the 2 files. So we're creating a list of the 2 files which are inside of it. The traffic accident data, and the radar and camera data. Next, we're creating the database engine. For that, we're using an SQL Alchemy function named create engine, which will handle that for us. And it will use the username, password, host port, and database name, which we said just now. And then we're looping through each of these files, uploading one by one. First, we're creating the full file path, so data / and the name of the file. Then we're reading the file in that path, the CSVs in that file path, and storing it as a pandas data frame. And we're defining the name of the table that we want to upload to PostgreSQL. For that, we're just splitting the database, the name of the table, and keeping the first part. So for the first file, the table will be named this, and for the second one, it will be named this other part. Next, we're uploading the data frames to SQL with this function here, with the name that we just selected, so the name of the file except the CSV part. And if it exists, it will replace that table in PostgreSQL so that we always have the newest data. Next, finally, we're just printing a successful message if we got to this point in the script. Now the script is ready to be executed, but first we're gonna have to run pip install again to make sure that the libraries that we added in the requirements text file are actually installed into their environment. So let's go here and do pip install our requirements txt and run this. This will install the libraries for us. And once it's done, the script is ready to execute. So let's do that. And once it's done, we get the message that the files have been successfully imported into PostgreSQL, into their respective tables. So we can go to pgadmin and actually check this. We'll first right-click and refresh to make sure that the updates are done. And then into the database public schema, under tables, we're going to find the two tables. We can actually check what data has been uploaded in here by right-clicking, view edit data, and just see the first 100 rows to see that everything has been done, has worked properly. Great. Now here's a possible mistake that or issue that we will encounter later. And it's that the coordinates have been loaded as text. So Metabase might not actually be able to read this. We will treat it when we encounter the problem later. But the rest looks fine. So let's go on to the next step, which will be to open Metabase. We'll go into my services, Metabase, and open. Start. We'll put English here. Next. Let's see. We'll put a password here. Let's see if there's any secret created for this. No. Okay, so we can just add anything here. Next. This already gives us the option to connect to our table. Since we have a PostgreSQL table, we'll hit that. Display name, we'll put the same as we did before. We'll go get the host. Once again, we'll paste it here. Copy the port. The name of the database is Postgres. The username is also Postgres. And we'll copy the password once again. PostgreSQL password. We'll get all the schemas and connect. Good. So now we're connected and our Postgres tables are ready. We can see that from here, PostgreSQL CP, which is what we connected to. And we see that it has already loaded our tables. Let's see, for instance, the traffic accidents data. And it's looking fine. So in the next step, we're gonna actually build the dashboard and see what insights we can get from this data. Dashboards in Metabase allow us to visualize and share data insights with our team. So let's create our first dashboard by creating on new in the top right corner, dashboard, and let's give it a name and create. Now we need to add a question. So questions are essentially a query, the result, and the visualization. And we can add a new one by clicking here. Let's select the accidents data. And one interesting thing that we might want to visualize is, for instance, the number of accidents per district. So we will select a custom metric, which will be the distinct accidents. And give it a name like unique accidents. And group them by district. And visualize. There are many visualization options that Metabase offers, like a table, line, a pie plot, an area plot. We will choose just a row. And we can customize it by clicking on this configuration icon here. We have changed a couple of things here, like the color and the label in one of the axes. But now we're interested in sorting the data from larger to smaller so that it's easier to inspect the results. We'll go back to the editor by clicking on this button here in the top right corner and click on sort. We'll sort it by the count of unique accidents and make it descending and visualize. Great. Now we can save the visualization by clicking on save here. We can give it a name and save. We can add this directly to the dashboard, so let's click yes to this dashboard. Now we can arrange what our dashboard looks like and add titles or filters. First, we'll move this one here. Let's see how we can make all of the districts shown. Move that to the right. Let's add now a filter. We'll click here. We'll make it a category filter. Now we need to select the column we want to filter by. So for instance, the age range, we'll make it a drop-down list, multiple selection, and done. Once we're happy with how this looks, we can click on save in the top right corner here. And it will show us what our dashboard looks like with the filter. So we can filter by accidents with people from 25 to 29 and 30 to 34, for instance. Add filter, and the results will be updated. This is the final result of our dashboard. We have added a couple new visualizations, some text with a hyperlink, the total count of accidents, a title, and even a second page with more details on the accident. So once we have arranged this and we're happy with the result, we can save it clicking on save on the top right corner. And it will show us how the dashboard looks like, including the interactivity. So now this dashboard will serve as the central location of our data insights on the traffic accident in Madrid. And that's it for Metabase. While Metabase is a great tool for creating general visualizations and dashboards, it's not created specifically for geospatial data. So that's where QGIS will come in. We're going to work with it in a second, but first there's some changes that we need to do to our database so that QGIS is able to read the data as geographical data. Because remember, there's a couple of columns that are read as text, and when it's actually a latitude and longitude. So to change that, we're going to right-click on the table and query it, and execute this part here. What this is doing is altering the table by adding a new geom column, which will have an expected type of geometry. And then we're updating the geom column with the transformed UTM coordinates. Since besides it not being read as latitude and longitude, we also have the comma as decimal point. We're going to change that and then transform it into the point. Then finally, we're creating a view with the distinct accidents and their location, since we may have more than one row per accident if there's more than one person involved. So now let's execute this. Query returned successfully. So now if we go into views, we'll be able to view the accidents unique view we have just created. Let's see. And we have a geometry point per accident. So now that this is fixed, we're ready to open QGIS. Let's go back to the BDTI portal and go to My Services, find QGIS, hit Open. We'll copy the password from my data, QGIS password, and paste it here. And open the tool. Great. Now what we have to do is to connect QGIS to the PostgreSQL database. So we'll go to Layer, Add Layer, PostGIS Layers. We'll hit New Connection, so New, and configure it. Now we have filled in the connection information, and note that we have added the authentication, so the username and password in the Basic tab, and we're storing that. Let's test the connection, and the connection is successful, so we can hit OK. And we should see here the schema. We're using the public schema. And here we have the accidents unique view that we have just created. So let's add it. This has been added as a layer into our QGIS project. Now we have the layer with the actual point data, but we're missing the map. So let's add this. This is done with the XYZ tiles part. We could just add this OpenStreetMap tile that is already loaded here. We double click it and drag it down so it's underneath the points. But we can also choose, let's delete this one. We can customize this. If we right click and add a new connection, we can find any link of a base map that we like. There's many beautiful open source ones. I'll just paste this one here and name it Pretty Map, hit OK, and drag it underneath here. So now we see the points on top of the map where the traffic accidents happened in the city of Madrid, but we're interested to highlight the hotspots and identify them so that we can take some action. So for that, what we're going to do is double click on top of the layer where the point data is and change in symbology the single symbol to heat map. Here you can adjust the radius and color gradient to visually highlight areas with the highest concentration of accidents, and the default settings work, but feel free to experiment with the parameters and fine-tune them as you need for your use case. We're just going to select the magma color ramp. Select the opacity to 0%, the radius to something smaller, maybe 1 millimeter, and the rendering quality to the best. Let's hit OK and magnify a bit. As you can see, QGIS generates a density map, allowing us to easily identify the most dangerous areas or accident hotspots in Madrid, like these intersections here or here. And these high concentration areas are where city planners or safety authorities should focus their interventions. Once you have created the heat map, you can save your work as a QGIS project for later use, or you can export the map for sharing. To export, you have to go to Project, select Import Export, and for instance, export map to image. We can hit Save. save it as accidents hotspots, and open the image we just saved. Now we're going to add another layer into our QGIS map, and this time it will show the locations of radars and traffic cameras throughout the city. And this will allow us to see whether there are any conflictive areas that could benefit from more traffic control measures, such as adding additional cameras or speed radars. So let's see first what that data looks like. We'll go to pgadmin, right-click, and view the first rows. Again, we see that longitude and latitude are read as double precisions, but we need those to be coordinates and a point. So we'll query this table and create the view for that. Just like before, we're adding a geom column that expects a geometrical point. And then we're updating this view to create a point from the longitude and latitude columns. So let's execute this. And query returned successfully, so we can go back here, open our project, and add the new layer. Layer, add PostgreSQL layer. So we see that after clicking connect here, there's the radar data. So we can click on it and add the layer, and close. Now we see the points where the radars are located. To make it more visible, we'll edit it by double clicking and changing the color. We can set it, for instance, to a more brighter color and hit OK. We have overlaid the accidents heat map with the radar locations, and this allows us to visually inspect whether the high-risk areas we identified in the heat map overlap with areas with little to no radar coverage. It could indicate an area where additional control measures might help reduce accident rates, and this is really helpful for city planners so they can decide whether to increase enforcement or implement new safety measures based on data-driven evidence. All right, so now we have seen the whole process. Let's just recap on what we've seen. So we have started setting up the BDTI environment, downloading the data with Visual Studio with Python, manipulating it and storing in a PostgreSQL database, and building a dashboard with Metabase, and finally mapping the geospatial data with QGIS. So all of these tools are available in the BDTI platform, but they're open source, so you can do it in your own computer without need of the BDTI platform. Of course, you won't have the advantage of the resources, CPU, and memory resources of the platform, but it's possible to create very interesting dashboards like this one. And also take into account that we've created a basic dashboard, so just descriptive, but you can work on predictions or work on more advanced analytics and visualize those with these tools. So it's very useful. Now let's just revisit the key question that we set in the beginning of the workshop, which was where are the traffic accident hotspots in Madrid and what measures can we implement to address and reduce these high risk areas. And we may propose some actions based on what we have seen. So one of these actions that we could propose to the public administrations would be to improve road safety. So we have seen where these high risk areas are. We can try to increase the number of traffic signs, upgrade the road lighting, or redesign the road layout just to try to improve those areas. We can also propose some targeted enforcement to increase the traffic patrol, surveillance in those accident-prone areas, and also perform some public awareness campaigns to just notify the population that those areas are more likely to, well, they have had more accidents. So just to contribute to safer driving habits and decrease the accident rates. By using tools like Metabase and QGIS, we have demonstrated how these data-driven decisions or actions can directly lead to actionable strategies for the public administration, and these steps can be crucial for improving the urban layout of a city. So now that we are finishing. We will upload all the slides and code and learning materials in the Skills Studio GitLab repo. We have already sent the link to that on the chat, but we'll have everything there updated. And notice that there might be some changes, like on the recorded demo, we have used hard coding for the passwords and for the credentials. This is not best practice. It was just used just to make things more straightforward and not to overcomplicate this workshop. But you will have there the steps on how we recommend that you do that, which is for creating a separate file with all the credentials and then calling that from the script. But yeah, make sure to visit this GitLab repo. It's very interesting. And you also have previous webinars and workshops there to retrieve. And yeah, before we wrap up, we will open the floor to any questions that you might have. So please write them down in the chat, and the team and I will be here to answer them.
Hi, everybody. Thanks a lot, Berta. This was really super interesting. I hope also that our participants enjoyed this session. And I think it's very clear what we try to achieve. We start from open data, so information that are freely available from Madrid in this case. And we start to, try to extract information from something that is just numbers. And then we were using this big data test infrastructure. But again, as Berta already mentioned, you can replicate the same data journey, you can replicate the same, let's say, development alone, downloading these open source tools that are available you can find in internet. So this was really, really interesting. Also looking at a different perspective of, numbers, geographical information, maybe even more trying to assess the quality of the data. It's something maybe you can do. There was a big distribution, men, women, and then there was others, if I'm not wrong. So this could be also something interesting to understand why we have this dirty data. So let's try to find some good question. I don't see anything in the Q&A, but I received another private question by the chat. So the question is the following: how do I handle large data sets that take to keep long to load into PostgreSQL? So probably the question is about what do I need to do when I have a huge data set and I need to ingest them in Postgre? So yeah. Please, then I can also complement for the big data.
Sure. There are many approaches you can take. I, for instance, would propose mainly 3. So one would be, you could break the data set into smaller chunks and upload them incrementally with a loop in a Python script or something like that. You could also modify the script that we have and you will have in the GitLab repo. So it's the one that we use, which we were using the toSQL function. This function has a batch size parameter. So it has an option for chunk size, and you can set how many rows you want to upload to Postgres at a time. And then, of course, make sure that your server has sufficient resources, so enough CPU, enough RAM for handling such imports.
Exactly. And even more if you're using, let's say, the big data test infrastructure, usually you don't need to download your data locally. There are different best practices in case you are connecting directly to the data provider. In this case, to the Madrid data portal, you can import the information, the data set directly from the URL. And maybe you can also try to implement a recurrent job, a routine that, based on the availability of this data set, can easily refresh the information and refresh the dashboard. Just one comment that I think it's very important to share with our participants about best practices is about password management. In this demo, we were showing you the easy way to just understand how to connect to database, how to define users, and how to connect with user and password. But in the real world, this is something you should not do. So you should not write your password and all your sensitive information and like login data in the code you're developing. So there are different ways of managing this. There are specific tools for password management. So this was just a demo, but please keep this in mind. Then I see another question from the chat. Is there any storage limit? Yes, of course, we are not offering you infinite storage. You can find all the technical specification in our technical documentation. If you go to the GitLab repository, the same one where you can find the code we are developing together, there is a specific section, now I'm going to post it, where you can clearly understand the different options we are offering in BDTI. That's something usually you define at the beginning of your use case, and that's something you can also change along the development. Then I have another question. It's exactly about automation. And if you can elaborate a bit more about how can I automate, the download of the information from the portal in this case, and the upload and the refresh of the dashboard.
Yes, of course. So there's many ways you can create a custom script or PostgreSQL triggers. But if you need a more advanced pipeline or combination of well, just create a workflow for that. You can have tools like open source tools like KNIME or Apache Airflow, which can be used to orchestrate these more complex pipelines. And this is not covered in this webinar, but we may touch in other webinars, and KNIME has been talked about in previous ones. And Airflow is one of the tools for orchestration that is available in the BDTI platform. So you can explore that one, or also locally. And yeah, it works great for that. So for automating the download, upload, and actualization of the dashboards.
Exactly. Yeah. As always, you have many different ways of, in this case, implementing automation. But for example, looking at the tools we are currently offering in the big data test infrastructure, you can use pure Python code and then try to schedule some job, or you can use specific tools. For example, KNIME, it's also good. We already used this in the past, and specifically Apache Airflow, as Berta was mentioning before. Then in the meantime, I just shared the link where you can see the user documentation, and you can filter the service capabilities. So regarding storage and also computational power, you will see that we have different tiers, and you can basically you can choose between all of them. Let's try to wrap up. I would say let's move to the next slide, and let's close this section. So already we have still in the pipeline very interesting use cases for the next weeks. The next one is about real-time data, again in the context of smart cities and urban insights. It's going to be super interesting, and again starting from open data, from data to action. Then you can subscribe also to the other webinars. The next one is again on urban insight. Then in November, we're going to have 2 different webinars, one about tourism and the other one focus on bicycle bike sharing. Try to forecast, so try to do not just that visualization, but moving forward with some more statistical concept and theory. Thank you. I will just wrap up also in terms of how to apply. Probably you are interested in this pilot. I hope you have maybe a good idea. You are part of the public administration. If not, maybe you can go to your municipality and propose an amazing idea to develop together. So feel free to contact us using this functional mailbox. Feel free to really check our website to try to have all this information, and try to contact us in case you have any question. Thanks again for your time. Thanks again for your interest, and we are more than happy to receive also your feedback, how we can improve for the next session, and spread the word around. This is free, and it's a great opportunity to work on data and to understand really how to move forward with AI, because at the end, data is the basic of AI. Thanks a lot, Berta. It was great, and have a nice evening, everybody.
Thank you, everyone. Goodbye.